right, let's talk about graphing equations. And we've graphed equations before, but today we're going to come up with a really simple way or a new formula for how to plot an equation of a line. Now, previously we've talked about intercepts before, and they're two of the easiest points to find. So if you would like to, please pause the video. I know we just started, but feel free to pause the video, find the x and y intercepts, plot them and graph them, and see if you can't come up with where the equation that line is. We've also talked about slope before. So if you remember the slope formula, m equal to y2 minus y1 over x2 minus x1. Feel free to find the slope using those 2 points and see if you don't notice something about the graph. I'm going to move fairly quickly through all those topics here in just a second, but again, I'll give you time to get that done on your own if you pause the video. All right, let's make this a quick process. Again, if we're talking about the x-intercept, again, that means that y is 0. So again, I'm looking for that second coordinate on my table. Well, if we're looking for the x-intercept and y is 0, that means that 3x plus 2 times y, 2 times 0 equals 6. Well, that means that 3x equals 6, right? 2 times 0 plus 3x is just 3x. And then finally divide by 3, and x will equal 2. So we're going to want the point 2, 0 on our graph. Then we can also, if we use the little more room here, plug a 0 in for the x coordinates. So again, 3 times 0 is going to be 0 plus 2y, which is just 2y equals 6 then. And again, if we divide both sides by 2, then 2y becomes y, 6 becomes 3, and I can plot the point, that was a bad 3 there, plot the point 0, 3 on my graph. Then if I draw a nice straight line, and I'm going to use a little bit of a shortcut tool here, so I'm going to draw a nice straight line through those points, right? Let's just draw here, straight through those points. And then don't forget to also include your arrows, right? Again, we've got arrows going up and down, arrows going down to the right there. Notice we could also find the slope, again, down here at the bottom. We wanted to find the slope of that line. We're just going to take our y coordinates and subtract them. So again, 3 minus 0. And the x coordinate that went with 3 was 0. The y coordinate, or sorry, the x coordinate that went with the 0 up here was the 2. And basically we end up with m equals 3 over negative 2, which is a negative slope, which makes sense on our graph. Notice we went down 3, right, from positive 3 up here, and then right 2 over to 2, right? Down 3, right 2, down 3, right 2. And that's really the idea of that slope, is that it can quickly find a lot of points for us. I can just keep on counting down 3, right 2, or up 3, left 2, up 3, left 2, up 3, left 2, and I can find lots of coordinates. Now, let's take one more extra step here. Let's take our equation and we'll write y as a function of x. Now remember, what that means is solve for y. So if I take 3x plus 2y equals 6, I'm going to solve for y. So the first thing I'm going to do is subtract that 3x. I want to get that off of the left side. 3x minus 3x disappears. We have 2y equals. On the right side, it's a positive 6 and a minus 3x. I'm going to go ahead and write the x first. Just remembering that really we're adding those two terms, right? We're subtracting just as good as adding, as long as the negative stays on the 3 plus the 6 there, right? Then it was a positive 2y that we brought down, so I'm going to divide by 2. And you might notice already, if I divide that first term, well, there's that 3 halves showing up again, right? And then plus 6 over 2 is plus 3. Well, now wait a minute. I've seen these numbers before. My slope was negative 3 halves, and my y-intercept, remember, was positive 3. So what we've just figured out, and if we try it with numerous other equations, you'll see that this will hold, is that if we position everything in the right places, if we make y a function of x, and we get an equation that looks much like this, we can call that slope-intercept form. The number being multiplied by x is going to be our slope, right? For every x that we move to the right, I'm going to move down 1.5. For every 1 to the right, again, down 1.5, or grand total, down 3, right 2, right? That's that idea of slope. So as x changes, the rate of change, remember we've called slope that before, the rate of change is that 3/2. But again, if x was 0, where do we start from? We need somewhere to begin. Well, we've got that plus 3, right? So when x was 0, we were up at 3. And then from there, we do that rate, down 3, right 2, down 3, right 2. Again, that's slope-intercept form. Y equals mx plus b, where m is the slope, and b will represent our y-intercept. Y equals mx plus b. Let's see how that can help us graph quickly and smoothly. Again, the first thing we need is to have y be a function of x. So if you have standard form like we do up top here, what we're going to want to do is solve for y. So I'm going to subtract 3x from both sides in this problem. Y equals negative 3x plus 2. We typically want to write that x term first, but don't forget that negative needs to stick with 3, right? That's negative 3x and a positive 2, again, together. Then I can identify, again, from my y equals mx plus b formula, the number multiplied by x will be my slope, that negative 3. Or if you prefer to think of slope as a ratio, we can say that's negative 3 over 1. And my b value, or my y-intercept, again, will be that positive 2, right? It's always mx plus b. Well, that gives me somewhere to start. Again, a y-intercept is always a coordinate 0, y, right? Where x is 0, y would have been 2. So I'm going to start up at 0, 2 on my graph. Then I'm going to count down 3, right 1, down 3, right 1. And I'm going to get lots of points without actually having to plug in numbers, right? It always took forever when we had to make a table of values. But I guarantee you, if you try plugging in 0 into your equation, you'll get a 2, right? If we did make a table of values very quickly here, I will guarantee you that you plug in 0, you're going to get 2. When you plugged in 1, we would get negative 1, right? That next point that we found down here. You can also use that slope a little bit backwards. What if this slope, instead of being negative 3, were positive 3? But over negative 1, isn't that still negative 3? So again, we could also go up 3, but go left 1. And you'll notice we'll get a nice straight line, right, through those points. Don't forget to label your graphs. So I'm going to label that we were counting by ones. And we have our graph done already. It doesn't get much faster than that. So let's go ahead and try a couple more problems here. If we can identify the slope, right? Again, what was multiplied by x is my slope, and my y-intercept is what's added on. Well, that means I can start up at 3 here, and I can count out up 1, right 2, up 1, right 2. Rise over run. Or, again, since I can go from left to right or right to left, what if I went down 1, left 2, down 1, left 2? I could also make my line go out to the left. And because all of those points are on my line, all the points between those points would be on my line, right? You can think of that 1/2 slope as saying, well, for every 1x that we travel, right? Think in your equation here, technically we're going to go up by a half for the y coordinate, right? In my equation. When x is 1, we'd get a half. When x is 2, we'd get 1. When x is 3, we'd get 1.5. We're going up a half. So again, I could also go up a half, right 1, up a half, right 1. From each one of my points, and notice now I get even more points between my points. And all of the points on that line, right, are technically points that make our equation true. But I didn't have to make a big long table. I didn't have to take forever doing that. So again, let's do the same thing over here at the right. What if we said, again, our slope is a half, and our y-intercept this time added on is a negative 1. Start at negative 1. Right, that's our y-intercept. We're talking 0, negative 1. And I'm going to go up 1, right 2, up 1, right 2, down 1, left 2, down 1, left 2. And just continue that pattern, right there. Now you might notice that both of those lines look fairly familiar. Right? I'm going to put some labels on here. They look fairly actually relatable. I shouldn't say familiar, but relatable. Neither of those lines ever seems like they're going to run into each other. Do you remember what we call that? We call those parallel lines. And why aren't they going to run into each other? Well, every time this one's up 1, I go right 2, up 1, right 2. Well, the other line's doing the same thing. Up one, right two, up one, right two. We started in different y-intercepts, but again, we're rising and running, right? Our slopes are the same. Parallel lines, again, are two lines that never cross, but they're also lines algebraically, right? The definition we want to remember is that they're lines with different y-intercepts, but the same slope. Parallel lines always have the same slope, right? They always have the same slope. Let's do one more equation here just for good measure. Again, if we're not in y equals mx plus b form, right? We're not in that y equals mx plus b, right? What we call slope-intercept form, right? It hands us the slope and the intercept. Then let's get it there. Let's subtract 3x on both sides. 4y equals, again, negative 3x plus 8. And then we'll divide by 4. And y equals negative 3/4 x, because they don't really divide very well, right? But 8 divided by 4 does make for a nice 2. Let's start up at 2, right? Because this is going to be our y-intercept, 0, 2. But now we also have a slope, right? Rise over run of negative 3/4. So I'm going to fall 3 units, go right 4 units. Now I don't really have any more room on my graph, but remember I could also go the other direction. Instead of going down 3, right 4, why don't I go up 3, left 4? The more points we have, the easier it is to aim for them, and we'll be able to nicely draw a nice straight line through our points. And again, label a couple of lattice lines, and we have a nice looking graph, quick, simple, and easy. If you have any questions about graphing with slope-intercept form, right, y equals mx plus b, talk to your teacher. Otherwise, have a great day.